So I think last time we got to this point, we were trying to make these classes. And my attempt was to talk about like wood paneling there, right? And maybe put green and yellow. Just go for a whole 70s vibe. Wood paneling. So we were talking about, well, how wide would each piece of wood have to be to cover that thing if I wanted to use 5 pieces of wood? Wood paneling, you with me? So that physical representation, our brain should just latch onto that and just be cool with that. It's the kind of computation our brain is like, I can deal with that, that's cool. So it's exactly the same computation I want to make here. The rectangles in my histogram are my wood planks, right? And how far it's got to go across the data is how far it's got to go. So the class width is the range divided by the number of classes. How far it's got to go divided by how many you're going to use is going to tell you how wide each one has to be. So on this data that I gave you, somebody remind me, what was the high and the low value from that data?
45.
The highest was?
45.
45?
Lowest was 0.
And then we picked 5 classes, is that right? So we got a class width of 9. Okay, so I'm just trying to catch up with myself. So then our classes would be 0 up to, but then the next class is to start at 9. So this class has to actually stop at 8. I love it. All right, so I think this is about how far we made it last time. We made these classes. Are you guys semi with me here? If you weren't here last time, I might have been a little bit quick, but just stay with me. We kind of missed out on the whole goal. So that class is 9, so it's 9 width, so this is going to be a 9 width, so this will go up to 17. And you just keep going, 18, 27, 36. And let's see, on this side it'll be 26, one less than down there, 35. And this will be, yeah, it would be 44. And normally you wouldn't have to worry about it. It's only when this comes out to be a whole number that last one you're going to have to make it one bigger to suck in that last data point.
What if there's 2?
That's fine. Whatever. How many you're going to suck that value in? However many there are. Cool. I like it. Instead of making a whole other class that I didn't want, those are just right on the edge of this class. You just suck them in. How are we doing there? Okay. And then the frequency. I think this is where we definitely left off. I might even have the data still in here. I did put it in here, right? Yeah. Oh no, somebody redid this whole thing so it's all empty. Okay, let's see. Yeah, those dorks. Alright. So, hopefully some of you guys still have your data. If you want a calculator, you can borrow one. Let me see, this person had data. Ooh, not really.
You can use my calculator to have the data from.
Oh, you can just help me. All right, so last time we went over, and we'll do it again, you'll hear a bit later, with some other data I want you guys to use. We went over how to put it into the calculator, right? You put it into these lists. So you're going to stat, edit, and then you can put data in. So I think it's pretty obvious we're going to be going here a lot this semester, right? Okay. So once you get the data in there, one thing you can immediately do is to sort it, which is very helpful for this. So if you still have the data in your calculator, let's have you help us out. Once you sort it, you can see how many are there from 0 to 8. I think we got through this a little bit. 12? 9 to 17? 18 to 26? 12? 5? 4. Bless you. Okay, allergic to data analysis, I don't blame you.
Yeah.
A lot of people are. Okay, so this is almost all of section 2.2. Section 2.2 is all about the creation of this table. One last thing it kind of adds in there is humans have developed something. They've developed a lot of things, but one thing they developed to help us make sense of this is percentages. Percentages make a little more sense to us. All right, so especially if I add more data here, I want to know where a big chunk of the data sits. So how do I change these into percentages, which we're going to call relative frequency? Yeah, because how many data points were there? 39. So there's 39 data points. So what percentage of the data points are in this first class? 12 out of 39. So somebody help me out there. Like 31% almost or something.
Yeah.
0.07%.
Do it again.
0.307.
Ooh, I was right on there. All right. So this will be 0.307, or you can make that 31%. Just round that. We can round these decently much because we're going to be doing this by hand. 30.7 is basically 31% when I draw it, right? Okay. So 6 out of 39 would be
15%.
yeah. So that would be 0.153 something.
384.
Gotcha. So about 15%. You guys all with me here? Does everybody see where those numbers are coming from? No? So in this class here, I have 12 data points. So I don't have all the data points. I don't even have half the data points. I have 12 out of 39. So that I can make into a decimal, which I then can make into a percentage, right? And real quick, everybody remember how to go from decimal to percent? From decimal to percent, I move the decimal place that way. From percent to decimal, I move it the other way. Right? So you put decimal percent, you put the letters down in alphabetical order, and it tells you which way to go. It's crazy. All right, so here, I would move that over once, twice, and I can round that up to 31%. So forth. What about, and now this one again, we got the same thing up here. We got 31% again. And then here we got,
13%.
who is it?
13.
13? And then 4 out of 39. 10%. And let's see, will these add up to be 46, 77, 900%? Yay. Now, sometimes it won't, of course, by rounding, so don't freak out if it doesn't make 100% exactly, but it should be really close to 100%. If you get 95%, that's not rounding. You did something wrong. You left somebody out. Something went wrong. Okay, how are we doing so far? Okay, good. I like that. Some of you guys are vigorously, that's good. All right, some of you guys are still very bored. That's all right. That happens with statistics sometimes. So that's section 2.2. That's basically all of section 2.2 right there. Talks about making the classes, setting up the frequency, just counting that, making percentages out of those. That should be old news. Section 2.3 now says, take all that, what you just did, and make it into a histogram, something nice and visual for us. And I kind of gave us a little word of you guys up here. Let me ask anybody, if you see this pointing the wrong way, let me know. I need to use my TA hours and get somebody in here for my camera. Little camera person. Or they could be a big camera. I don't care, as long as it can be right there. When I make the histogram, what do I not want to have show up? Gaps, right? Because then that's sort of telling people that you left people out or something. Something went wrong. If I use this scale based on these numbers here, what's going to happen? I'm going to get gaps. It's going to go from 0 to 8, and then 9 to 17. There's going to be a gap between 8 and 9. You with me? So I'm going to show you what Triola likes to do, and then I'm going to show you what I was taught. And then I'll let you guys, you can pick whichever way you want to do. I don't care. All right? This way is kind of a little gross because you have to realize if I had something, for some reason I had 8.3 was a data point, If 8.3 was a data point, where do you think it would go? Yeah, in here, right? This first class. If I had 8.6, where would it go? Here. So that shows you that you actually have, you don't have 8 as a boundary. This is the class limits. But the boundary for this class would be 8.5 on that side. Right? And then where does this one start? It starts at, well, 8.5 really. If you want to go to 2 decimal places or something, you got to be careful. But let's just stay with this. Our data is 1 decimal place. So our data is whole numbers, right? Our data was whole numbers on that sheet. So I only have to go out to 1 decimal place for this. Is that kind of cool? Now, personally, I'm a little biased because I was taught the other way. But the other way takes away a lot of this ambiguity. These are your class limits. These are your class boundaries. And just to give you a physical example of that, there's a limit to me, right? I'm Jeff until right here, and then it's not Jeff anymore. You with me? This is my Jeff limit. But then I have my own personal boundary where if you step up in my grill a little too close, that means you're trying to tell me something. You with me? So I have boundaries that are out here, but I have limit that's like physical limit. I'm not here anymore. This is not me. I'm there. Yeah. So this is like me, and this is my boundary, my little protective layer. And some of us have larger boundaries, some of us closer. You guys semi with me? So I want to give you a little silly example of what this is trying to say. If you want to do it this way. This is the book way, so this is kind of nice. The book is a little backup for you. My way, the way I was taught using, that's what it says, I was taught. So this first class would not be 0 to 8. This first class, and here's why people don't like this other way. Because you guys don't normally like X's or interval stuff. So watch. So I'd say the first class would be, oops, got it. And the next class would be, you can really see the class width everywhere, right? Ambiguity. Now, the way to say the word is kind of ambiguous. Ambiguity is completely gone. Where does 8.7 go? First one. Where does 8.9999992 go? First class. 9 down here, right? So class limits, class boundaries are the same. This is if I was completely cool with you, like being right up on me, which I'm not. So don't try that. You guys kind of. So either way you like. This is not in the book. This is my way that I was taught, and I always still do it this way. Really, this is the way the book does it. Several books do it this way. Some books do it that way. You can do it either way you want to. Just make sure it makes sense. All right, how are we doing so far? And this is really cool because then when I go to graph this, there's no gaps. I don't have to invent something like this to take care of the gaps. So let me first graph this doing it this way. What's going to be down here? What's going to be the boundary on the side? So it's got to be outside of that. Like 9 had to go down to 8.5. 0's got to go down to negative 0.5. And then and now what's really cool is you know the width is 9. So you just keep adding 9. So this is going to be 17.5, 26.5, 35.5. And then these just kind of go right along with it. Just add 5 over here. I really want you to understand, though, really the only reason class limits exist is so it takes care of that gap problem. That's the only reason they really exist. If you did this way, you wouldn't have to make them up. But it's either way you want to do it. This is in the book, the same. So when I go to graph this now, I'm going to graph it based off of this here first. I would put negative 0.5 on there. I know this is just for labeling purposes. Negative 0.5, 8.5, and then so forth. But that's right, the last one is off.
May I ask a question?
Sure.
So the limit is going to be 0.5 below the class number, whereas
The boundary is going to be, yeah. So these are the limits. And these are the boundaries.
So limits and boundaries are interchangeable?
No, these are the limits.
Okay.
These are the boundaries.
Okay, so
Cool.
the limit is 0 to 8.
Good.
And the boundary is 0.5 below, 0.5 above.
Good. I love it. Yes, ma'am.
So when you're doing it, you said the way you taught, that takes away from the boundaries completely.
Exactly. If I wanted to do the thing here, I would just say 0, 9, 18. Right? Yes, ma'am.
So if I have 8.5, would it go on the first
Ah.
or the second?
If your data was decimal data,
So it's just 8.5.
if your data was decimal data,
Okay.
then these would have to be decimals to start with. These aren't decimals currently because our data is not decimal data. It's a whole number data. Would I care over here? No. I don't have to change these at all, no matter what the data is. So I don't know if all of you guys understand what I'm saying. I'm obviously trying to get some of you guys to go this way. Some of you guys don't like this way because all of a sudden there's X and there's inequality symbols. But this is completely, what's the word, unambiguous, disambiguous? This is completely clear as to where things would go. So over here, either way you do it, the first class, whatever you call the first class, goes up to 12 on the frequency. Right? But let's make a relative frequency. I think that's what I asked for, is it?
The percentage, yes.
Yes, the percentage, cool. Because that is what makes more sense to us.
So if you're doing the way with the X, just to clarify, would that replace the ranges under class, or would it describe?
Yeah, I would have put this here.
Okay.
I would never put any of this down. I would have put this right there. And then started going with my frequency. Yep, cool. I like it. Some of you guys look very excited about this. Yes?
So there's no, for that one, there's no boundaries then, right?
Boundaries equal the limits.
Okay.
They're the same thing.
Yeah.
Really. Yeah.
I like that
Okay.
one better.
Me too. So I at least want to show you. But I understand why some of you guys might not want to do it this way, because this is in the book, explained in the book. You have the book to go back to. This is not. So I understand why some of you guys might not want to do it this way. So either way, I'm not going to say, oh, you're one of those people. No. I don't care. Either way. Yeah.
So how come a negative 0.5 is past
Yeah,
0?
good. Because this is just for labeling, really. This is not the true axis. This is just for labeling. I want all my data representation to be on this side. It's just kind of like convention to not go through an axis.
Well, yeah.
So I pulled the negative over here just so I can put my labels here and I can still show my rectangles over there.
Okay.
Cool. I like it. Okay, here we go. So, if I want to do the percentages, good God, that's a lot of stuff up there. Sorry. If I want to show my percentages on the scale there, how should I make my scale? I want to go up to 31%. How should I make my scale here? Maybe I can do...
Tens?
Sure, 10 will do 10, 20, 30, 40, and that's all I really need. All right? So make sure your scale makes sense. I hate it when somebody has all their data's down here because the scale doesn't make it. You have all this room you haven't used. So it's really hard to tell the differences in heights. Use some space, right? Make your scale make sense. So this first class would go up to 31. And then the next one up to 15. And then 31 again. And then 13. And then 10. All right, so by hand, that's pretty damn decent by hand. I'm not going to expect it to be perfect, but do what you can. So one thing I can ask you, I don't know if this came up yet. I think it did come up. Oh, yeah, sure.
Are we supposed to do a relative frequency histogram or a regular frequency?
For the handout, what's it say? Oh, it says frequency. So if I want to do a frequency, I would have just based my scale on this. And then I would have went by maybe 3s, 3, 6, 9, 12. Does that make sense? The picture, would it have looked different? Hell no, the picture looks exactly the same. Either way you do it, it's just the labels on that are different. But see, now as a human, I can look at that very quickly and say, oh, none of them are half. There's nothing in the majority, right? And I can see very quickly where the most people are working. Most people either don't work much, or of course, no benefits for you. So a lot of people work right there, right at the, that magical line that if you crossed it, you would actually get some benefits, some health care. But no, not for you. I worked at a hospital, so I didn't have health insurance, but I had doctors that gave me stuff on it. It's a good idea if you're looking for a job. Okay, so and real quick, you must always label what the hell's going on. So this is going to be relative frequency, and this is what? What would I put down there?
Hours worked.
Good, I love it. So it doesn't have to be super long. Don't just put classes though. It's nowhere good enough. I need something physical related.
Hours worked per week.
I like it. That's fine. Cool. All right, so if you leave any of that stuff off, you're going to lose some points. Yeah, how are we doing so far?
We label X and Y, like should we define that this is the X and that's the Y axis?
No, because it really isn't. This is the hours axis, and this is the percent of people axis, right?
Okay.
Yeah, so these labels replace the X and Y labels.
Okay.
Yeah. Say again. No, I don't care about that. Title's pretty much in there already. All right, so here's what I want you guys to do. I think it's pretty much all I had on the sheet, right? Yeah. I want you to do everything we just did. Everything. Class width, make your frequency and relative frequency table, make a histogram. This is actual data from the 41 people who have filled out the survey. Any of you who have not filled out the survey, it is due today, and today's not over, so you got time. So when you leave class, do it. I'm not sure why I have different numbers of people that did the anonymous survey versus the basic information survey, but I'll just live with it. The guys are like, I don't want to give you any information, Jeff. I just bet you.
You're collecting this?
What's that?
You're collecting this handout?
No.
What was your question? What are you not understanding?
All right, guys. Can you all see that? I try to make it big, obviously. So do everything we just did that's on that handout I gave you. Do all of that stuff for this data. So this is from the actual data you guys are giving me. This is 41 people and what they told me the heights of their moms were. I love that some of you guys know it down to a few decimal places. That's actually a little freaky, but it's all right. Mom, stand still. Yes, ma'am.
So it's just the last two sessions from the first handout or do you know?
All of it. Yeah.
Okay, question. Are we filling out information that like on B, C, and D for this graph here?
Doesn't
or
matter.
Is it on a separate sheet of paper?
You can do another sheet of paper. Most of you guys have probably filled in your handout.
Are we going to turn this in?
No.
Okay, thank you.
But if you want practice, now's a really good time. Yes. Yeah. You've got to count it. So you actually have to go into your list and just count how many are between this and this.
Or do we just make it up? We could do however many amount of classes for this, right?
Actually, let's do this. I'm glad you said that. Let's all make 5 classes so it's easier for us to compare. Because if I do one up on the board, I don't want to do like 3 different versions for. Let's all do 5 classes. If anybody used 10 classes on this, I'd have a problem with that because this is a very big sample. No. So the smaller the sample, the closer to 5 classes you use. The bigger the sample, the more you go towards 10.